Okay, we'll get started. Go ahead and respond to the online poll if you haven't done so already. And then and today I thought, I don't know, I have a few things I want to just talk a little bit, but I mean, I guess that's what I do every lecture. But anyway, so you guys are studying for your final exam. You're wrapping up your last homework assignment and whatever. And I guess I just wanted to share a little bit of perspective on, I don't know, life or whatever. Just because I think you've heard me say numerous times about test scores and grades and how these things don't define your life, and I sincerely mean it. And so anyway, I just wanted to tell you, kind of share a little bit of my life story, I guess, to kind of tell you where I'm coming from with this perspective, and why I keep saying this. So anyway, much like many of you, in high school I worked really hard, and I did my best to get good grades because I thought that's what a good student was supposed to be, and I was not the rebel type, and so I spent all of my hours studying, trying to get good grades, and in high school I got into my dream school. I got into Caltech, which is just a few miles away in Pasadena, and I said, all right, I got into this school. I'm going to go there. I'm going to study, I don't know, physics or something. You guys laugh because maybe you had similar thoughts or something before arriving at UCLA, or I don't know, maybe not. So anyway, so I go there, and I don't know, I made friends and whatever, and then the first day of lecture comes, and I'm like, wow, this is a lot of stuff. And then we had they're also on quarter system. So 5 weeks in, I have my first round of midterms, and I'm just like, this is hard. And basically the story is, I managed to pass all of my classes in my first quarter. My second quarter, I didn't do as great, and then and continually my grades went down, and then in spring quarter I failed all of my classes. I think I got a D in one of them, and this was really hard for me. And one thing is, Caltech is a lot smaller than UCLA, so all the professors know who you are, and then they write individualized report cards. They don't just file away letters, but it's like in elementary school where the teacher leaves comments. And my teacher, or my professor, wrote, Miles Chen was the weakest student in the class. And this was absolutely devastating for me, because I had come from high school where I'm always doing at the top of my class, and my identity at that time had revolved largely around my academic performance and my grades and all of this. And this was I wasn't good at sports, no surprise there, but so I felt good about myself when I did well on tests and when I did well in classes. And so anyway, when this happened, this was totally crushing and defeating, and I became depressed. And it's kind of funny because I see the same phenomenon happen here at UCLA. Because you talk to your professor and they would say oh, well, why don't you study with these other students who are doing better in the class? And I'm just I don't want to study with them because I feel stupid when I study with them. And so I ended up studying with other people who are also struggling in the class. And I think in our group of 5, 3 of us at the end of our first year said, we're dropping out. We're not coming back to Caltech next year. So at the end of my first year, after, and it was very sad because I felt like I had worked so hard in high school to get here, and then once I was there, I have to, give up my dream and drop out. And so at the plan, I was thinking of just going back to community college, maybe try to apply to transfer to a 4-year school after that. My parents, fortunately, they were very supportive and loving. And my dad said, if you're miserable here, we don't want to see you like this. We think you should stop and try something else out. Anyway, they found another school for me to attend in Michigan, and I visited in the summer, and I went there, and I went to Michigan, and I did a lot better. I don't ever have to go back to Michigan again, but no offense to those of you who are from the Mideast or Michigan. It's just I grew up in Southern California, so like when the weather suddenly became cold, when it's like 50 degrees outside, I'm like, I gotta wear a jacket. So in Michigan, it would reach like 20 degrees, 18 degrees, and it'd just be the whole month of January is just ice. So anyway, I don't miss that. But the change of scenery and change of kind of classes and all of that, was good for me. And at the time, it was very the whole failing all of my classes and all of that. That was it was very difficult and rough at the time. But I do believe that through that experience, I learned to let go of my grades. I learned that I realized I had an unhealthy. I had placed an unhealthy value on grades themselves. When who I saw myself as a person was tied up with my academic performance, that created just kind of this unhealthy atmosphere where when things started to threaten my grades, I found it tempting to cheat and do whatever it took to try to protect these things that I'd held on to so dearly. And I think just by having all of that kind of stripped away and taken from me, I realized who I am as a person is not defined by these things as grades. And I know a lot of you are thinking of grad school, and in that regard, grades do play a role in admissions and things of that nature. But I guess in all of this, I just want to emphasize that I don't want your identities to be tied up with these externalities. These things where you feel like you're constantly being assessed and measured by external forces, whether it be grades or your position at your job or what other people think of you or whatever. I don't know what other metrics exist in life. I think your sense of value and worth has to come, I think, from somewhere else that is not as subject to outside forces and things like that. So anyway, I just wanted to share that perspective with you, and just kind of tell you a little bit about where I'm coming from, and not just I'm not just some person that's just like trying to poo-poo what you guys are working so hard on, because I know as students, all of you are working very hard to do well in your classes, and that is an honorable, and that is what you are supposed to be doing because you are students, and this is what's going on. What I want to do is just kind of encourage that what you're working hard for is not, does not become an unhealthy thing that has power over your life. So anyway, that's what I wanted to say. I don't know. I don't know if you have any other questions about how I ended up here. Oh, and here's the other thing that people don't like to hear, but I'll say it anyway, is that, you know, when you apply to grad school, when you apply for jobs, when decisions are being made about things, we don't necessarily, or in a lot of times, we don't have full control over what happens. And it's absolutely true that, you know, when you decide, like from the other perspective, when you're trying to decide who to admit and who to hire and things like that, it's difficult to know who exactly is the best candidate. You know, you only get just a small glimpse of evaluating a person, and you're supposed to make a decision based on that. And so the end of the bottom line is, the people who make the decisions, they try to do the best they can. They don't always make the best decisions regarding who to admit and who to hire. And at the same, and what that means is on the people who are being hired and being admitted, there's always just there's always an element of luck, okay? And it could just be that whoever was making the decision at the time had a good feeling about you for, whatever else, whatever reason it might be, right? You know, there are things like standardized exams and stuff that are supposed to be helpful in terms of evaluating people in a less subjective way, but at the same time, how somebody performs on an exam is not necessarily reflective of who they are as a person or how much success they'll have in the future. And so everything else, comes through in the other parts of the application or the resume or whatever it might be. And there's always going to be, an element of luck there, and it's difficult to know, and that always doesn't sound good because that means it's no longer in your control, right? If it comes down to luck, it means you are not the one in control, and that there's other forces that decide your fate. And sometimes it doesn't feel good that way, especially when you feel like you're on the receiving end of bad luck. But at the same token, sometimes you end up being on the receiving end of good luck, or grace, or whatever we might want to call it. And so I know there's a bunch of drama right now about people bribing their way to get into USC and UCLA and all of these schools, and I fully understand the outrage, and rightly so. That is not right. And while recognizing the injustice of that, at the same time, I feel like my admission to UCLA graduate school was, a lot of luck as well. I don't, there's no way to know anything about the future. And, even like the person you decide to marry, you have no idea like what's going to happen in the future, right? You might spend like 5 years dating the person and say, okay, well, the person has proven themselves to be trustworthy and all of this, and then things change, people change, and I think we should desire for the person that we are with to change and evolve, not necessarily in the way that we expect or maybe even want, but growth, personal growth, is always just a part of life there. Anyway, yeah, my whole story of grad school here and how I ended up being a professor or lecturer here at UCLA, that's a whole nother story. Maybe I'll share with you another day. But basically, I always feel like I don't know how I ended up here, but I did. So, and I feel really lucky. So, yeah. I don't know. Sometimes I end up repeating the stories and stuff, and so I'm sorry if you've heard all of this before. But anyway, good luck as you guys study for your exams. But get your sleep, okay? Sleep is super important. I always, I don't like seeing students have, having these mental health issues of depression and anxiety, and I think that's something that affects a lot of students too often these days. And and sleep is one quote easy solution that generally helps in many of these things. Okay, a lot of times maybe you need a lot more than just sleep is not going to be the only answer that fixes everything. But a lack of sleep often exacerbates these other things. There's probably other things that need to change in a student's life to fully address the issues of, anxiety, depression, and other mental health concerns. But a lack of sleep certainly does not help. Okay, anyway. I don't know, I was going to talk about Shiny. I don't know if you guys wanted to see Shiny stuff, or I should just talk about, I don't know, other random... What? Yes, question. What's that? How did I end up at UCLA? Oh, this is... My story is not typical. So after I graduated, I went to Michigan. I went to Kettering University. I graduated, got a degree in engineering, and I really absolutely loved studying. It was industrial engineering, which, if you're not aware of, is about process design. So industrial engineers don't design, parts like a mechanical engineer or computer components or even software, but they design a process, meaning like what's the best order to do, these set of tasks, like how many levels of approval should you require, who should be doing quality control, these kinds of things, just a process, designing a process. But anyway, I absolutely love that. I interned with UPS for a few years during that time, so I was part of the industrial engineering team at UPS. I did not make I was part of like package tracking, but the industrial engineering department, I don't know if you've heard of stories about UPS, but they're the ones who make the decision like UPS trucks should avoid making left-handed turns, and they design the routes for like maximum efficiency. They decide which cities get a direct truck link versus, if you're going to send a package to Ohio, should it go directly there or should it go, make stops in Oklahoma and things like that. And so a lot of stuff there, and it was fun. But I remember, having a chat with a manager, and basically, the long story short was that, in more or less words, the manager encouraged me to consider making a career somewhere else, and not necessarily at UPS, but, based on his thing. I think UPS is a great company, and I don't want to knock that for any place, but based on this experience, talk with the manager and what my goals were and what he valued and things like that. His thing was saying, maybe I should try a different company. So I applied elsewhere. I went to another company. But basically, at the end of the day, I was not super excited about working in the corporate world. And again, I don't want to knock anybody who plans on going into industry or anything like that. But as far as maybe, where I wanted to spend my time, it was not necessarily a good fit. So I thought maybe I'll try going back to grad school. And at the time, I really wanted to stay in LA, and because I grew up in LA, I liked being home. All of my friends and my church was in LA, and so I was just like, I want to stay here. So in reality, I applied to UCLA on a whim, and it was the only one school I applied to. And they didn't have an industrial engineering program, but I remember taking a bunch of statistics courses in college because I really enjoyed it. And so I said, well, maybe I'll try statistics. And I didn't have any like math background and things like that. This was back in like 2006, 2007. And this was before machine learning, big data, data science. Data science was not even a thing. That nobody had even heard of that term. And so statistics was very traditional and whatnot. But anyway, I applied. I got waitlisted, and then I guess the first round of students did not accept their admission, and so they let me in. That is very atypical today, because today it's now like thousands of applicants or hundreds of applicants, and you let in only a little bit, and all of these spots are very competitive. But back in 2006, not as many applicants. Our cohort, there was 7 that joined the grad program at the time. That was the time when 102A for the entire year was offered once, and there was one section, and there would be 35 students. And then, and I'm totally serious. We can they even have like the registrar's data here, and like 140 SL and 141 SL had like 7 students or something like that. I know it sounds ridiculous. It sounds so crazy, but this was 10 years ago, 12 years ago. This was a different time. So, and now we're gonna have 210 students in my one class here. But anyway, you just have to change this from 19. If I just change it to 09 spring, so this data pulls up. So 2009 spring. So let's just take a look. 102C, one class, 32 enrolled. 141, 12. Is a different time. So anyway, I got in because statistics wasn't as popular back then. I'm pretty sure if I applied today, there would be zero chance of me getting in. But anyway, I got in, and then I stuck around for like way too long. But that's where I found out I loved teaching, or at least talking. And so, I mean, I think I already knew that. And then again, when I graduated with my PhD in 2015, so it took me 8 years between it was very long. That was when statistics was really taking off, and they said we need to hire more people to teach because our classes are getting huge. So I said, oh, I'll do it. And they said, oh yeah. And they said, oh yeah, you've been a good TA, so we'll take you on. And that's how I ended up here. Anyway, so I'm thankful. I feel like I've got my dream job. Along the way in grad school, fell in love, got married, had kids. A lot happened in those 8 years. So that's just something else to keep in mind. You might be thinking of going international for grad school, which is totally great. There's a possibility you fall in love during your grad school years, and you might stay in that country for the rest of your life. So just be mindful. Maybe that's what you wanted anyway. But University College of London has a program, and so people will say like, oh, I'm going to go to Britain to study. I'm like, okay, you might stay there forever. Could happen. So anyway. Okay, well, now that story has been told. And now I feel like, okay, well, I was going to talk about Shiny. I don't know if you guys want this, but yeah. All right, so shiny. What is shiny? Okay, well, I think shiny is one of those things where we hear a lot about it, and we're like, oh, I want to learn shiny. I want to make an app with shiny, but it also just feels very like far out there. And in my opinion, is that shiny is designed so that it's very easy to code something up. Okay, it might be time consuming. It might require a lot of writing a little bit of this and a little bit of that, but a lot of the elements are made so that they're kind of like putting Lego pieces together. Okay, you just kind of specify what kind of piece you want, where you want to put it, what things it's gonna do. And then you build up the app that way. Okay, so in that regard, I think Shiny is very easy to work with. Much like Legos, I think Lego pieces, it's very easy to work with Legos. But then if you want to build a masterpiece, you want to build something with a bunch of little intricate parts and elements, then yes, it will be time consuming, and it will require some planning in the upfront. But as far as what is required, it's actually not too hard, okay? And so if you want to create Shiny, first of all, you should just go on Google and type in Shiny, okay? And, okay, so you're gonna get this song from Moana, and then Jermaine Clement, whom we love, and then you'll click the first actual thing. So you could just type in R Shiny, and then you'll get this. And then under get started, there's tutorials, okay? And of course they plug Data Camp, which is I don't know if they have a partnership with RStudio, but Data Camps I think is a very good thing, if maybe a little bit expensive. But that's available, and anyway, you can just start by going through these tutorials, okay? And they're very good, and it's enough to just get you started. They're very easy to follow along with. Otherwise, you can just, if you just say File, New File, Shiny Web App, okay? Then it will start by creating this original, this thing here. And you don't have to do anything. If you just create a new one and then immediately click Run App, it starts its first Shiny application, okay? And what we have here is the app says it's going to plot Old Faithful Geyser data, okay? And we see the histogram here. And basically what it's doing is it's just taking the data from our data set Faithful. I can't actually do that, but there's a data set talking about how long it was, the number of minutes that passed between Old Faithful Geyser eruptions. Okay, so I think you guys know about Old Faithful, but basically in Yellowstone National Park, there's this thing in the ground that shoots steam periodically, but it's been named Old Faithful because it happens on a very regular basis, where a lot of other things, where you're looking at geothermal things, it's not as predictable. Okay, so Old Faithful, very predictably, shoots stuff out of the ground at these intervals. Okay, and then what the Shiny app does is it says, let's change the number of bins. So if we increase the number of bins, this is what we see. If we have 50 bins, and then if we reduce it down to 8 bins or 15 bins. So at 15 bins, you get, you start seeing you see the bimodal shape of the thing, and as you increase the number of bins, you can kind of see its effect on how the histogram looks. Okay. So it's not entirely sure what, or I don't know, maybe scientists have really studied what causes the bimodal distribution. But anyway, this is basically your basic Shiny app. Okay. And so if you wanted to create a Shiny app, there are you can create a multiple file thing, but there's basically two parts to a Shiny app. To run the Shiny app, you call this function Shiny app, and you say UI is equal to an element that you create called UI, and server is equal to server. And basically, there's two parts. UI for the user interface. This is what is being displayed on the screen, kind of in the web browser. Okay, so when you click Run App, it basically opens a web page, and you can actually open it up in your browser yourself, and it does the same kind of thing. Okay, but here maybe I want to resize my page or something like this. Okay, so just it runs like this little. It creates a website. Okay, and the way it works is you define what it is that the user will see in the UI portion. In the UI portion, you're going to define this thing, and then on the other hand, you have the server portion, and the server says this is how you're going to take the inputs from the web page, and this is what the computer will do and calculate before it returns it back to the web page for display. Okay, and so we can. I think it's worth just kind of taking a look at this. Okay, and so the UI starts off just at the top. It says we're going to create a fluid web page. Okay, and so this basically just says we're going to create a web page that has some dynamic elements that can change based on it's not going to be a static page. It's not going to be something that just displays stuff that is unchanging. It's going to be stuff where the user can interact with these things and whatever. Okay, it starts off with a title. No big surprise there. And then the one thing that that the user can do is we create this thing called Sidebar Layout. Okay, and what the Sidebar Layout is going to have is it's going to have two parts. It's going to have the main panel and the side panel. Okay, or sidebar panel. Okay, and so if we look at our app, this is basically over here is the main side where we see the histogram, and on the left we have the sidebar. Okay, and so now inside the main panel, what we're going to have is we're going to have this thing that says plot output, and we call this thing the distribution plot. So this just says plot whatever distribution plot is equal to. Okay, so create a plot there, and then you have the slider input. Okay, which says when you create it, this is what it is. It comes with the label number of bins, and it goes the minimum value is 1, the maximum value is 50, and the default value when it starts off is 30. Okay, and so that's all that appears here. And whenever the user changes this number from 30 to say 14, it's going to update a variable titled bins. Okay, so this is what defines the web page. Okay, so this is the fluid page part. And then the other part is, okay, well, what does R need to do to create the output called distplot? Okay, and so on the server side, okay, we have to create a function called the server, which is always going to be kind of the a function of input and output here. And what we say is in output, there's an element called distplot, which is what we have right here. Okay, so in the output we have a thing called distplot, and the one function that distribution plot does is it it's going to run all of this code. So we run this code called render plot, okay? And basically it says, all right, what we're going to do is we're going to take, so the data set is called faithful, and we're going to just take the second column, and this is going to be x, okay? So faithful is just the second column of x, and then we're going to define, so if you remember how a histogram works, you can kind of specify the breaks with just an integer, but here we are going to we're going to take the input bins, okay, which comes from right here, input $bins, okay, and we use that to define the sequence of breaks, okay? And so the sequence of breaks will start at the smallest value of x, will be a sequence from minimum x to maximum x, and we say length out is equal to bins plus 1, okay? Because if you just set bins equal to input $bins, I don't know if you've noticed, but sometimes when you ask R create like 20 bins versus 21 bins or something like that, the plot actually doesn't actually change, right? It's just because that bins number that you put in here is almost like a suggestion, right? But if you give it an actual sequence and say this is where the breaks are formed, then R will take that command like a literal absolute truth that must be adhered to, okay? So in order to kind of update the bins and make sure that, you know, when we just change this around, we're not like we'll actually get something different between 20 and 21. We don't just say take input $bins. I mean, we could do that, but you'll see that if I did this, then we'll have that situation where if you say 20 or 21, a lot of times R doesn't actually make a difference. So we'll go ahead and we'll do this. So here's 30, and then say, you know, you can see where if I reduce the number of bins, like R is just like, okay, that's a nice suggestion. I'm going to do what I want, right? So here I'm changing the bins. And I think we've kind of probably noticed this. And then so finally, like when I get down to here, R is like, oh, okay, you know. And this is probably not an ideal user experience where you have something like this. So that's why we bother with the manual creation of the bin sequence of bins here, okay? So we take the slider input, which shows up here as input $bins, and then we create the sequence there, and then we specify those as the breaks that we use for the thing, okay? Okay, all right, and so that's kind of the default Shiny app, and so if you wanted to do other things, you know, you could do things like color will be input $color, and what we'll do over here is in the sidebar panel we will throw in so now I have to do Shiny input types, add control widgets. So you can, these are all kind of the different things that we have. Maybe I'll have a radio buttons. And so just with so here we'll just do radio button here as just one of the things that we want to include on the sidebar panel. Okay, and so we'll call this color, and our color choices will be red and I don't know, blue. Okay, and so when you do the radio choice, so over here you put in kind of the thing that's going to be displayed, I believe, and then whoops, not blue, but red, and here I guess we can do gray. Something, all right. All right, and then and so we have input color right here, and this is the thing right here, and I think we'll try that. Whoops. Okay. So obviously I made a mistake somewhere. Let's see. Oh, I have to close that off. Okay, that will make a difference. Okay, and then so now now we have the thing, and we can choose whether we will want. This is not exciting, but now you can just add stuff to the thing accordingly, and you can choose the things as well. Okay, so you can so in my opinion, it's rather simple. Okay, it's a simple idea, much like Lego pieces, but again, you can get lots of complexity by kind of adding a whole bunch of these elements together. Okay. There's other tutorial examples, okay? So here is one. We'll let me go ahead and close this thing, okay? And so here's an example where the output is going to be text, okay? So over here, in this thing, our output was a plot, okay? You can have output where the output is text and a table, okay? And so, so here, so you have verbatim output. So this is just what, like if you type the command into R and it's gonna print out text, the verbatim output is exactly what R would output verbatim. And then if you want like, if the table that comes out is going to be like a data frame, okay, you can have it format a little bit nicer so that it looks a little bit more like a prettier HTML table. And so here is, you can look at different data sets, pressure and cars and things like that. And so I think, the cars is like the speed of the vehicle, and distance is the braking distance and things like that. And you can see this relationship between how fast the car was going and how long it took to stop. And then you can, and this is just another input thing where you can say, where you can enter in the text, or you can use these up and down arrows to reduce. And so basically you can already kind of imagine what the underlying code is doing, right? One part is going to be just summary of this stuff, and then the other part is going to be head, where number of observations is going to be head, comma, this value, okay? And then over here, we have this drop down that basically specifies which data set we're going to look at, okay? And so basically, so we have the select input, which is this thing where we have this drop down thing. And then the numeric input is, so that's going to be, the label is data set, and then the numeric input is the label is observations. And again, with the numeric input, you can kind of change these things. And then as far as the main panel goes, there's two portions. There's the verbatim text output and the table output, okay? And that's all listed there, okay? So again, these are just kind of like your different Lego blocks that you can combine together to create what you want. And then as far as what the data does, okay, you're going to say, so here we have this thing called a reactive and a switch, okay? So there's a switch function that's going to take in basically what is written up here, where our choices were rock, pressure, and cars, and it's going to choose the data set input this way, okay? And so so this is going to allow you to kind of choose the data set, okay? And then so the data set just gets an alias of whether it was rock, pressure, or cars. and you can see summary of the data set goes into output $summary, which is just the verbatim text output. And then over here for the view, okay, we have head of the data set where the input number of observations is the input, but then we call the function render table, okay, so that it produces a prettier looking table there, okay. And so that's just another quick example. And pretty much, you know, once you understand that there's just these two elements, the UI, which is what gets displayed to the user, which is going to consist of input options and things that get displayed in the output, and then the server which takes in those inputs, decides what to do, and decides what to return. Then conceptually, Shiny is quite an easy thing to work with. The reference and the documentations will just kind of list off, and if you look at the gallery, we'll list off basically all the different kinds of inputs that you can have and all the different kinds of outputs that you can have. And it's mostly an exploration of those things, and then it's really just up to your creativity to decide how you want to put these things together. And so you can check out the gallery where they have, you know, really impressive things. But I would, you know, just like many other things, I suggest starting simple, okay? Kind of this, here's like a simple k-means clustering thing. Just start with a few simple things, and then and you can build up to something a lot more complex. And then the widgets gallery tells you all of the different kind of elements you can have for inputs and all of the different elements you can have for outputs. Okay, sorry, I've gone over my time. Anyway, good luck as you study. It's been a pleasure having you as an instructor, so thank you. And yeah, we'll see you guys next week for the final exam.